Hello everyone, this is KP the MFG, and I would like to, well, you've seen something very familiar with this if you've seen any of my, going on now the 125th video. I've had this quite a few times, but you know, the test is around the corner and we need to really nail this down. I guess it is. I don't know. I will say that I don't know when y'all take your test now, but I'm thinking it's going to be either late April or early May. They may have changed the date since I've been in school, and now that I'm retired, I don't know. But anyway, be that as it may, and if you're a calculus student, this will help you out as well. Let's start. It's a 2012 free response question number 3. You're going to be given a graph. This is actually the graph of F. Okay, yeah, this is the graph of F. We're going to call this F right here. Okay, and we have a function g that's defined as the definite interval from 1 to whatever x is, f at t dt. Now, it does says find the value of g at 2. That's a little easier. I want us to find g at negative 2 on this one. So if you look at this, g at negative 2, g at negative 2 equals, well, we're going to put negative 2 right here, f at t dt. Now keep in mind, this number is less than this number. So you have to remember that when you're doing this, that you put your negative sign and then flip the signs around. That is why I wanted to show you this. That's the major reason for that one. Well, we got to go all the way from negative 2 to 1. Alright, so if we look at this, now listen, we are looking at area. When you're talking about integrating something, it's always going to be area, or in some other cases, volume. But you're looking for, you know, in these cases here, it's going to be area. And if the area underneath the x-axis, or we say y is equal to 0, if this area is down here, it's going to be negative. Well, unless you had to flip the sign, okay, and it's below, then it's going to be positive again. I've had that situation in one of my many videos, so be aware of that. But in this case, we're looking at this from negative 2. Let's get a different color. We're looking at this from negative 2. We're looking at this area. We'll call it area 1. And all the way to 2. All the way to 1, rather. Okay. And we're looking at this area right here. Alright. Now, let's look at that, because I may need to erase to keep this area going, but this is the initial way to set it up right here. You need to realize that you've got to put this negative sign right here. Okay? Alright. Now, actually negating this is going to be negative, and this is actually going to be positive. But anyway, let's just look at it. Let me erase this now. And you're just substituting. You just got to realize that's what you're doing. Okay, let's put this back up here. And let's see if we can, let's see. Let's put it over here. I'm going to say we're dealing with negative, integrating from negative 2 to 1, f at t dt. Okay. That's really what we're looking at here. Okay. Alright, so let's look at it. Let's get the area. This is a triangle, so 1/2 So in other words, area 1 is really 1/2 the base, which is 1. Now remember, I know I got a negative sign out here, but I'm just looking at the initial. Now the height is 3. That's the y value. Alright, look for that y value when you're taking a time test like that. Alright, there it is. So this is equal to 1 times 1 times 3, 3 over 2. Alright. Okay, now remember, we're going to negate all of this in just a moment. Alright. Actually, it's going to be the negate of the area 1 plus area 2, which that's what I'm calling this area 1 and area 2. Maybe we need a darker color. Let's get purple. Sometimes I wonder if this green is going to be working. Let's get A2 now. Now we got to know the area of not a circle, but it's a semicircle. So we know that a circle is pi r squared, don't we? The area of a circle. Well, a semicircle is going to be half of that. Okay, so this is going to be, r is 1. See, that this is 2, right? See, here's your center right here. And I know this is -1, although it doesn't show that. I don't need that. This radius here is 1, and this radius here is 1 going in the other direction. So I know that my radius is 1, so I'm just going to square 1, and that's going to be, well, pi times 1 squared is just pi, so really we just have pi over 2. So we're negating this, so this is negative 3 over 2 plus pi over 2. I'm taking it that I did everything correct. Just looking at it just a little bit. Yes, it is. And so you're going, oh, by the way, this is negative because we are down below, so this is actually going to be negative here because it's below. That's right. Let me make this plus negative a minus sign like that, really, because it's a negative pi over 2. Okay, because we're below that. Okay. Alright, now then we're going to distribute the negative sign, so this is negative 3/2 plus pi over 2, or we can just say then pi over 2 minus 3/2. And that's how you find area. Keep in mind that you're looking for, in this particular case, we're looking for not total area, but we're looking for net or displacement area. And so when it's below here like this, you are going to take the negative. Do not count this plus this. Now, okay. Or if you do make it plus, this is plus a negative this. Okay, whatever. But anyway, you got to remember, if it's below this axis, it's going to be negative. Okay. Alright, so if you were asked to find the absolute value of this, then you're going to add both of these up, okay? But anyway, that's that. That's what you got to remember to do on that one. And that takes care of this one. Let's look at part C, okay? Let's erase this. Alright, this is actually, see, that was part A, wasn't it? Okay. Let's let's do that one. Okay, I skipped the C. I guess maybe it's because I want to do C so bad, but so badly. Well, here we go. Alright, just remember how to set this up, and I just want you to nail this kind of stuff home. I just about have a funny feeling that this year you're going to have something like this on one of those 6 questions. I think it's 6 questions. Anyway, Just get that hunch. I get a hunch that maybe you're going to get a separation of variables problem, okay? Where you have an initial condition, and you got to separate the variables. I just have one of those feelings. You get one of those feelings that you get a particle motion problem. You just kind of get that in your mind that you may get something like that. A variety of different problems, but anyway, let's go to B now. Let's see, it says we want to find G prime at -3, and well, let's just find that. And then I want to say that they are doing G double prime. Alright, this is B part. Well, this is the kind of stuff that you need to nail down too. I mean, if you can get some points on this, on these types of things, that's what I'm trying to get you to do, is help you to get all the points you can on that. Because if you're multiple choice, you get a third of these, which on the multiple choice, I'd like to think you can get more than that. But if you get a third of them and you get all of this, it's at least a 3, maybe a 4. I'm not sure, but you know, I mean, you can pass this test. I'm telling you, if you can do these problems here and make 7, 8s, and 9s on them, you know. All right, well, here we go. G prime. Now remember, here's G right here. G prime at X. Remember, you're taking the derivative of a definite integral. So if you take the derivative of this, then that's just f at x. All right. So if I'm looking at G prime at 3, I'm just looking at f at 3, and I know that this is the function of f, or -3 rather. Ooh, it's not 3, and I did that when I practiced it. I put a 3 here. It's -3. All right, so f at -3 is something right here. I got to figure out what that point is. Okay. Well, I know that it's in between -4 and -2. I want the y value for this. So since these are the y values, 1 and 3, I can simply do the midpoint formula and I can find out what that y value is. So 3 plus 1 over 2. Remember, you know, your midpoint formula is you add up the x's and divide by 2, you add up the y's and divide by 2. Okay, and that's what I want. I want to know what this midpoint is, and actually I can pretty well tell just by looking at this. If this is a 1 and this is a 3, what do you think this has to be in the middle? Yeah, 2. And it is going to be. This is 4 over 2, which is 2. Alright, so we know this answer is 2. Okay, like that. I just used the midpoint formula. That makes it easy for me. Now I want to do f double prime at G, or G double prime. G double prime at X is equal to, well, if I, you know, so right here, G double prime at X, or G prime at X is f at X, then G double prime at X is, I'm just taking the derivative again, which means that is f at X, f prime at X. I'll get it right, f prime at X. And that's what you need to show. You need to show this, and you need to show that. And let them know that at least you know something. Get some kind of point out of this. Alright, so G double prime at 3 is f prime at 3. Now this is just the derivative of, now that means this is the slope, doesn't it? This is a slope. -3 again, y'all. Look at me doing that. The slope at x equals -3. I want to know what the slope of this line is. I want to know what the slope of that is. Well, again, slope, y2 minus y1. So in other words, now let's do it this way. Alright, so let's put it over here. y2 minus y1, so 3 minus 1 over negative 2 minus negative 4. Okay, like that. Alright, so this is going to be 3 minus 1 is 2, and 2 plus, minus a negative is plus. This is 2 over 2, it's equal to 1. You probably could get away with doing rise over run, okay, up to right 2. That's still going to give you 1, okay, like that. Okay, 2 over 2 is 1. So this here is equal to 1. Alright, right there. And just understand that. This derivative, the slope of g is just f. And you just took you took the derivative of the antiderivative. You took the derivative of the definite integral. That's the definition of, well, that's just applying the fundamental theorem of the calculus, either part A or part B. But anyway, that's the fundamental theorem of the calculus. That's what that means right here. You are applying that. They're testing you on that. Okay? Do you understand that? Yes. Okay. That's what you're looking for. Okay? They want to see if you understand that. Okay, that's B part. Let's see how far we can go. I want to see maybe if I can get to the C part. Alright. Have such a limited space, I have to erase every time I do a new problem. Alright, we gotta have that. We're not doing that prime there now. Okay. Alright, there it is. And thank you for bearing with me as we look at these together. I love doing this. I used to be afraid to do this, but now not so much. Not so much. You just got to figure out what you're looking for. Alright, we have a horizontal tangent line, the graph of G. So G has a horizontal, let me abbreviate that, tangent line. So tangent. Alright, we're just going to say horizontal tangent. That's going this way, isn't it? Alright, okay, so let's see. It says find each point. Okay, so for each of these points, determine whether G has a relative minimum, a relative maximum, or neither. Okay, now, and justify your answers. You see this. This is where. Okay, so in other words, really you're doing G prime because you're talking about a horizontal tangent. You got to take the derivative of G. Alright, so really you're saying that G prime at X is again equal to F at X, which by the way you're saying equals 0. That's where F crosses the x-axis. Alright? We're looking for that point. This is the graph of F here. That's what we're talking about. It's right here and right here. Folks, x equals -1, -1, and x equals 1 are your horizontal tangents. Or horizontal tangent. Let's just say horizontal tangent, HT. Alright, horizontal tangent, HT. Let's look at this. Above the axis is increasing. Below the axis is decreasing. There's a change of sign. At -1, there's a change of sign. So at this one right here, so at x equals -1, there is a change of sign, GN, from positive to negative. Therefore, G is a, let's see, increasing, decreasing. Okay, increasing, decreasing, and make it increasing, decreasing. Here's -1 right here. Okay, increasing, decreasing. So we have G has a relative max. A relative max. All right. At x equals -1. Okay, like that. All right. Oh well. What about x equals 1? I think this is going to be my last, my last one that we do for the lack of time. We will take a little time to do D maybe later, because I do want to get into that. We may have time, but we'll see. Alright, so I want to see, I'm going to check on x equals 1. Alright, notice that both of these are below. Okay, so let me erase this. But you do have a horizontal tangent here. Okay, don't dismiss that. You still have one, but now what's going on here? Is there a sign change? So let's just put it x equals 1. This is below the x-axis. To the left of 1 and to the right of 1 is below the x-axis. Alright. At x equals -1, there is no sign change. That's what they're looking for. Is there a sign change? Increasing and decreasing, you have a max. Decreasing and increasing, you have a min. But if you got decreasing and decreasing, you have neither. So there is no sign change. Therefore, G has no relative max nor min, nor relative min at, make sure you say which one. Okay, they know it. You already said it right here. You don't have to repeat it. Okay, don't have to be that redundant, I don't think. At x equals 1, there is no sign change. G has no relative max, no relative min. Okay, be redundant. At x equals 1. You want to be redundant. That's okay. Now they got it. You can't miss it now. Okay. I'm going to try to do this point of inflection thing. I'm going to try to be as brief as possible with D. Okay, and I may run out of time, and if I do, then just understand that at least you got the first 3. I'm going to try to be brief about this because I am running low on time, I'm sure. Alright, so that's horizontal tangent. Look for these places of intersection here. Now, point of inflection. Alright, so you're looking at, when you look for point of inflection, you are actually looking at, you're looking for G double prime in this case. Well, in other words, you're looking for the second derivative. You're looking at the second derivative. Okay. Now, at this idea here means, you're looking at, instead of where they cross, you're looking at the places where you are increasing and decreasing here, right here. You're looking at these points here. Okay. It's G double prime is equal to F prime at X. Remember, if you do double prime, make this F prime. That's the slope. That's the slope there. Okay. You're looking at this slope and this slope. Is there a peak here? Yes. This looks like a point of inflection here. Alright, so increasing and decreasing. Alright, so at X equals -2, you have the signs change. Signs change. Well, and all of them, okay? From, in this case, positive, okay, the slope changes, alright? Positive to negative. Alright, and you're talking about the slope here, okay? Alright, and then also look for another one. Here's one down here. Alright, right there at 0. X equals 0. Alright. Same idea. Negative to positive. Signs change. And also one more, and that's here, even though this looks weird. This is going up, this is coming back down, so at X equals 1. Alright, 3 places. Signs change. You're looking for those slopes. Changing in slope. Okay. Signs change. Okay. Right there. Okay. What it says, the graph of G has point of inflection at X equals 2, X equals 0, X equals 1, because G double prime at X equals F prime at X changes sign at each of these values. Alright, these change sign. Okay, alright. At here, here, and here. And that's what you're looking for. Positive, negative here. You got a point of inflection here. Here. Alright, right here at X equals 0. Okay. Here, and then at X equals 1. Signs change here. Okay, that's what you're looking for. Okay, as long as this graph is continuous, that's what you can do. Alright, there it is. Well, I didn't think I could get this part D in, but that's all of them. This is what I want you to be able to just nail that thing really good. Nail it to the wall, if you will. Okay, KP the Math G signing off. Make sure you do, if you haven't subscribed already, subscribe. Please do that. If you'd like to make a comment, please make a comment. And if you'd like to hit that like button, just give old KP Math G a real big old smile. But if you don't do any of those, I just hope you get something out of this. It's not for my glory, it is for yours. It's for your benefit. KP the Math G signing off. Ladies and gentlemen, have a great, great day.